Okay, Wildcats. Today we're looking at Tuesday, September 18th, solving absolute value equations, and that's going to be on page 12. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, solving absolute value functions on page 12. Solving. Definition. Absolute value of x is x is greater than or equal to 0, and negative x when x is less than or equal to 0. It's a true piecewise function. Solving steps. Step 1, isolate the absolute value. Step 2, apply the definition. Step 3, solve. And step 4, graph the solution. All right, so update your notes. All right, now your notes are updated. Let's take a look at the examples. Example 1. Step 1, and let me see if I can adjust the lighting here. So hit that for a second. That help. Back one. Aha. All right. Now, step 1, isolate the absolute value. It's already isolated. So step 2, apply the definition. So 3x equals 9 and 3x equals negative 9. All right. Step 3, solve. So we divide by 3, x equals 3. Divide by 3, x equals negative 3. Last step, we're going to graph the solution. Now, whenever I graph on the number line, I always put 0 because that separates the number line into negative and positive. So then all you have to do is put negative 3 in the negative side and positive 3 on the positive side. All right, let's take a look at example 2. All right, step 1, isolate the absolute value. So we add 1 to both sides, so we get the absolute value of x equals 4. Step 2, apply the definition. So x equals positive 4, x equals negative 4. Last step, graph the solution. So again, I put the 0. So now I have the negative side, positive side, so negative 4 and positive 4. All right, before we start example 3, there's a mistake on your paper. It should say x, absolute value of x plus 4. So if you could just update that now. All right, now it's updated. Let's look at solving it. All right, so first isolate the absolute value. So here we subtract 4 from both sides. So the absolute value of x equals negative 1. All right, now this is special in the case that absolute value can never equal negative 1. So we would say that this is no solution. So your solution looks like that. There's no point on the number line, so no solution. All right. Now let's take a look at example 4. So first step, we're going to isolate the absolute value. So we divide 3 by both sides. So the absolute value of x plus 1 equals 1. Step 2, apply the definition. So x plus 1 equals 1, and x plus 1 equals negative 1. Last step, we're going to solve. And before I do that, I want to make sure I have space for my number line. So here we subtract 1 from both sides, so x equals 0. Subtract 1 from both sides, x equals negative 2. All right, let's take a look at example 5. All right, here we isolate the absolute value, so subtract 3. So absolute value of x minus 1 equals 0. Apply the definition. So x minus 1 equals 0. X minus 1 equals negative 0. Now, It's kind of a special case in that positive 0 and negative 0 is still 0. So when you solve, you're only going to get one solution. So add 1 to both sides, x equals 1. Last step, graph your solution. All right, last example. All right. So first step, you isolate the absolute value. Okay. So first step is we divide by -1. So the absolute value of x plus 1 equals -3. Now, just like example 5, the absolute value can never equal a negative number. So this is no solution. So in our graph, there's no point on the number line that's a solution. All right, so with that, if you understood all the examples, start working on an assignment. If you didn't, then understand that you could come to class and work in a small group, or you could be working in that teacher-led station. So with that, have a wonderful Wildcat day.